LabVIEW yields many benefits to engineers and scientists who have become frustrated with the implementation details of traditional programming languages. LabVIEW is differentiated by its graphical general-purpose programming language, known as G, but is modern in the sense that it offers an integrated compiler, a linker, and debugging tools for a sophisticated programming experience. Now, the purpose of this video is to cover some of the semantic differences of LabVIEW programming to help you understand how to get started writing LabVIEW graphical code. We will do this by building a LabVIEW application that will generate and display a sine wave based on frequency and amplitude user inputs. The first window you see when launching LabVIEW is the Getting Started window. Now, this window is intended to be a table of contents to help you locate recent files and helpful resources. For our case, we'll just choose blank VI. Now, VI stands for Virtual Instrument, and this is a form that we'll use to start writing our LabVIEW code. As with most modern programming environments, LabVIEW has a set of tools to allow you to develop interactive applications that can be compiled and run. The user interface, seen here on the left, is known as the front panel. You add elements to the front panel by right-clicking to access the controls palette, and then you navigate to the control that is needed for your application and you drag and drop it onto the front panel. Because our application requires the user be able to specify the frequency and amplitude of a signal, we will need two controls. We'll use a knob control for the frequency and a numeric control for the amplitude. Now, both of these controls can be located under numeric. So first we'll drag down the knob control and place it on the front panel, and then we'll go back into the numeric palette and grab a numeric control. Now remember that we wanted to name the knob frequency and the numeric control amplitude. You can modify the representation of numeric data by right-clicking on the numeric control and accessing representation. You can see that we have the ability to change the representation here, but in this application, double precision will be just fine. Now, LabVIEW has built-in user interface graphs that can be used to display data. And we'll be using one of these on the front panel to display the signal that we'll be generating. We can access the graph control just as we did the numeric controls. So we'll right-click to access the controls palette, then we'll navigate to Graph, select Waveform Graph, and drop it onto the front panel. And the last thing that we need is a stop button to control the execution of the application. You can access a custom stop button from within the Boolean palette. So we'll navigate to the stop button and drop it onto the front panel. After you develop the front panel, you add code using graphical representations or functions to control the front panel objects. In LabVIEW, you add this graphical code to the block diagram. The block diagram is seen here on the right side. The first thing that you should notice on the block diagram is that the numeric control, waveform graph, and the stop button that we placed on the front panel are represented on the block diagram as well. Now, the colors are very specific to the data type that is being represented. And in this case, the double data type that's being represented with the frequency knob and the amplitude numeric control are represented as orange. Now, in a very similar manner to the mechanics of the front panel, you can add elements to the block diagram by right-clicking to access the Functions palette. You would then navigate to the function that you need for your application and drag and drop it onto the block diagram. LabVIEW has built-in assistance to help engineers quickly complete common tasks such as simulating a signal. We can access a Simulate Signal assistant by right-clicking on the block diagram, going to Express, Input, and then dropping Simulate Signal Express VI onto the block diagram. Now, within this window, we can specify that we want to generate a sine wave and click OK. Now, LabVIEW G-code executes according to the rules of data flow. The data flow implementation of code is typically easier for engineers and scientists to quickly understand because they're largely familiar with visualizing tasks in terms of block diagrams and flowcharts. The data flow of a LabVIEW application is determined through wires, and these wires are used to pass input values into functions and return output values from those functions. Now recall that for our application, we would like to use the frequency and amplitude user inputs to generate the sine wave and then display it on a graph. To do this, we'll wire the frequency input into the frequency terminal of Simulate Signal and the amplitude input into the amplitude input terminal on Simulate Signal. This will force that simulate signal function to use the frequency and amplitude inputs and generate a sine wave based on those parameters. This function will then return a signal that we can wire into the waveform graph. Now you'll notice that when I wire the sine output into waveform graph, the graph automatically changes to accept the waveform data type. The program will now execute based on the data flow that we have implemented and will display the waveform data after it's been simulated. The last thing that we would like to implement is a way to make the application run until the user clicks the stop button. While loops are a perfect structure to implement this functionality. Now, since LabVIEW is graphical, we can literally draw a while loop around the code that we want to execute continuously. The stop button can then be wired into the loop condition to force the application to terminate once the user clicks the stop button. When implementing while loops, it's a good programming practice to add timing. Now we can add timing to this application by accessing the timing palette and then selecting a wait function, and then specify 100 milliseconds for the timing. We can now use the LabVIEW Run button to compile and execute the application. Now we can dynamically change the range of the knob button so that we can see multiple cycles of the sine wave. Now we can use the knob control and the amplitude control to change the frequency and the amplitude of the sine wave. And you can see that data is being generated using simulate signal and then being displayed on the waveform graph. Now when we want to exit the application, we simply click the stop button. Now that you've learned about some of the semantic differences of LabVIEW graphical programming, you should feel empowered to start creating your very own LabVIEW applications. As you continue on with your evaluation experience, keep in mind that LabVIEW provides you with a front panel for creating user interface objects and a block diagram to write graphical code that will control those objects. Additionally, you can easily recognize the data types of the objects on the block diagram based on their color, and implement application execution or the data flow by wiring the block diagram objects together. Thank you for watching this video on the semantics of LabVIEW graphical programming.